Hello, everybody. As we said in the announcement, I'll let her, and then we'll talk about this. Second day of week 4 now. So, exactly today, we're halfway through. I guess technically there's still a couple days of doing homework and stuff, but so halfway through the class. 8 week courses go quick, but somebody mentioned 16-week courses for this about game development earlier. It wouldn't help. We'd still run out of time. It it took me years and years and years to build up extensive knowledge of game development. It's fun. Hopefully, y'all are having fun, right? Couple weeks in here, enjoying a little bit. Yeah. When I was young, I made the first thing I called a game, which is a stick man. The basketball thing basically with a stick man and circling a hoop. And first thing I called the game. After that, I started trading my brother my turn on the Nintendo for his turn on the computer, so that I could do more of the making stuff. Uh, and it takes a while to build up. So even in 16, if it was 16 before, we still have a lot of time in this. In going with this time consuming, and there's so much to cover, right? All those different parts we tied together. So that's one of the concept things is today. So after today's conceptual lecture on probability is our main topic for today. After that, the second half of the semester, we're going to be doing good on so everything's going to, the rest of the steps are going to be explained in examples. I was thinking I'm going to make a good format. We do all the concepts in the first half with a little bit of clicking around on Godot. And then when we're doing the Godot examples, we already clicked around on it for a couple weeks. So hopefully be a little bit easier to follow as we get into the stuff there. So yeah, the main thing on the agenda today is probabilities. Uh, then I'll look at physics materials in the Godot engine. So talk about physics some, but if we make a rigid body, it just falls down and lands on the floor. We need how, how do we have the game engine take control of things like how bouncy it is? Or what's the opposite of bouncy? Godot uses the word absorb, but it's like a spring. As one of the default stretched out springs so that when it falls, it just compresses and then all of the, instead of bouncing, it's just the spring compresses in it. It would sit there. But the opposite of bouncing, it's called something different in every game engine because there's not really a word for it. But I guess the difference between dropping a marker and dropping a t-shirt, they hit the floor very, very differently. Friction, smoothness, roughness, those sort of things. They're built in there because we have to have a physics engine to get the boundaries around our objects, that physical shape, what the computer is going to consider the physical shape. And since we have physics engines and programmers can add little functions, one function at a time, they've basically built up, put in all the laws of physics already. So they're there to work with, which means looking stuff up. So I do want to make a note about that at some point. Also on the discussion boards, I got that sort of typo fixed from the first couple weeks. So moving forward, pay attention to the due dates on both due dates on the discussion board because there'll be a slight penalty if you don't get the initial post on time. Because I copied from a class where things were due on Wednesday, so it said submitted by Sunday, but in our class going to go on Monday, so it's submitted on Sunday. There's not really no class week's post on it. So I moved that back to fit our schedule. So moving forward, there'll be I think I said Friday. Has anybody looked at that recently? Several people have already gone through and done all of this. But make sure your initial post is due by turned in by Friday. That way your classmates have Saturday, Sunday, and Monday to respond. Basically the middle of the week. And then the second half of the week is for the replies. And then yeah, moving forward will be my regular grading policy of a point deduction. A late penalty on the post, the posting it, but I can't close the assignment at that time. I can't set a late penalty for half of the discussion board. Something like that. just make sure you get your initial post impact ratings. Let's see, probability, physics materials, and then a little note about tutorials. Some of y'all have heard me say it before. This class, we're looking a lot of stuff up. That's one of the things I want you all to learn. Is find good reference material, find things. There's an issue with tutorials though. I think a lot of people get this with software development and even more so with game development. Tutorials are introductory things, right? It's great for the first couple steps. You want that first step, how do I make a character move and get over? You're gonna be bombarded with tens of thousands of tutorials. It's a great introduction, but as you move further and further along, tutorials become a lot more sparse. It's an introductory thing, and we'll very quickly move past that introduction. I've seen a lot of people get stuck where they only learn to follow a tutorial for the introduction, and they don't know how to take those next steps. So what I always say, like to point out, is make sure you're using the tutorials correctly. So one of the things we're going to look at today, we're going to do some physics stuff. So we'll physics materials. So we'll look at rigid body stuff. So I'll start that real quick. Rigid body, and make sure you put 4 in there. There was some big updates for Godot 4 after a whole bunch of people got curious and quit Unity. And then there were some really, really great programmers. Same thing on GDevelop, whatever the latest version is. Whatever the version came out in 2020 is, make sure you put that number. It's a whole lot of just highly experienced, really good programmers quit Unity at the same time and started doing open source stuff. Because they wanted to care about a game engine. They wanted to work for do stuff for game engine companies where the primary goal was to make a game engine that could make good games. Not the other goal, the game engine is a side thing for Unity. But so that's a basic thing. We're going to find tons and tons of tutorials. If we look at the docs, basically the point I like to make is you always want to look at the documentation first. What is my screen doing?
Very interesting.
There's a page not really looking very good. Okay, actually, my phone will get better. I tried zooming out, but something weird with the CSL thing. List. So yeah, just a couple things on the agenda today because I'll be out of town the rest of the week. So, and I'm riding with the carpool that's leaving shortly after our class time. So we'll probably only go for a break time, but one of the things we're going to look at is physics. So when you're looking for stuff, always look at the official documentation first. So that's the user manual. Especially at the beginning, the time where you need those introductory tutorials, that's not going to make a lick of sense, right? If you're going to read through here, it's going to look very, very confusing. And be like, what are they talking about? This is hard to follow. This one's not too hard to follow. Actually, they have actual technical writers writing their documentation, not just programmers. This seems consistent that people that write really good programs don't always write really good paragraphs describing their programs. But this particular open source project actually hires technical writers to write their documentation. So the documentation is not bad, but that's not going to make a lick of sense. So what you want to do is go over and then read the documentation, then check the tutorials, but don't jump right back to your code. Don't use the tutorial to immediately learn that one single thing in your game. Use the tutorial to learn to read the user manual. So that after you get past that introduction level, you know how to read the user manual for, in our case, the Godot game engine. And then you have the full user manual of everything that can be done there. And you're used to the style of how it's written and have made sense of it. So make sure you're using tutorials correctly. So right? Don't watch this video to learn rigid body interaction and then put that right in your game, right in one single game, because for the next thing you need from rigid bodies, you'll have to do the same thing. Watch this, use this video to learn to read the documentation about interaction in rigid bodies. And if you do that a few times, you'll get used to how the documentation's set up. And then you won't have to dig through and look for tutorials for the specific thing you need. It makes it a lot quicker because then you usually only need a minute or two from, say, the YouTube tutorials. You only need a minute or two from the whole thing to make sense of the documentation. Once you see it start coming together, you can figure out what they're doing with it, and it'll be far more productive in the long run. So this is rigid body. We're going to look at this after we talk about probabilities. Apply physics materials, come back here and do physics. When we do a character body, we just have movement, right? We've seen that default scripting go a couple times. There's not one in a rigid body. A rigid body just has all of the laws of physics apply. And, well, we talked about this stuff. If we want to move, what we have to do is apply impulses or set of velocity, which it doesn't have velocity by default. So we actually have to create that in our script, define what the velocity is doing, which direction it's moving in, all of that stuff. So when we were doing that in that default character script, the question came up was is one better than the other? And on that script, it's kind of just a different style. But if we have to do the entire thing from scratch, we definitely want to work in vectors, because they have to be vectors anyway. So we have to create the vector and then break it down into components. And on that default template script, there's already a lot of the breaking it down part done in the background that we don't have to worry about. So it is important, but hopefully after that basic coverage of physics, you at least know what that sentence means, right? And remember the difference between an impulse and a force.
Definition for impulse was over here and force I written down over here.
Something like that.
Is force constant, impulse is
Impulse could cause more.
Constant stators where it would be the opposite of that. Force is instantaneous. Impulse was force over power. So the force needed to stop a moving car. That's the example I like. The car's mass is not changing; it's going at a certain velocity. Yeah. Impulse is how the force is applied. Is a moving car hit a brick wall or a bunch of bushes? Because to stop that car takes the same amount of force. But how do we apply that force, and how much time is it applied over? So we have to, when we're moving rigid bodies, all the laws of physics apply, which by the time we wrap up today, hopefully you'll want to do that instead of that default template. Speaking of which, after we talk about that, since lecture is going to be short today, since I have to leave, I am going to send a video and call it lab time. So it might be a good time to work on that, but it's a pool game that actually uses the laws of physics all the way through. It's a 2D version, but it should be a very easy expansion of 3D if you want to challenge yourself. Because you just go from circles to spheres. Pool balls don't go up and down, right? So it's a super easy extension from 2D to 3D. They will when you apply the laws of physics. They can, but in general, you're thinking about them roller direction. But first off is the last. Let's look at this real quick. While we're talking about all these things, the last of the concepts we need to talk about. I go into IB learning real quick. As soon as Zoom buttons get out of the way. Just a reminder about this list, because this is something you want to look at in all of your classes, not just ours. Ours is just the one to use as an example today. When you go to the syllabus, something required to be in all of them is the course outline of record. the description, but one of the sections there is the major course learning objectives. The things we are supposed to learn from this course, right? The checklist, you can think of it that way. In all of your courses, make sure you check this list. And if there's something that you're not learning that's on this list, those are questions you definitely want to ask. I'll remind you since we're about halfway through. Number 6, the mathematics and physics principles used in game development. We talked about vectors, and we talked about physics. We'll talk a little bit more about physics today. But another big important one for game development is probability. And this is sort of the opposite of physics. Physics looks clean on the board and then gets to be a mess when we get to our code. Probability looks like a mess on the board and gets really clean when we get to our code. So they're an interesting opposites there. So the definition of probability is the mathematics modeling random phenomena. And it is the plural Latin word that's important. Because probabilities are kind of boring if we take individual items. Probabilities are a lot more interesting than things together, right? Like cards are a standard example of probability. It's way more interesting. Anything that has multiple players that's all right off the bat. Whenever they're distributing differently. But that's mathematical definition. So let me put up the mathematical definition of random here. And my black marker stopped working. Definition of random. Since you probably haven't encountered random in a math class, there's kind of 2 of them here. Similar courses lead to dissimilar events. I don't know why I just read it that way. I'm sorry. Similar causes lead to dissimilar effects. In my notes, I put event because we, if we're talking about programming, we think about events. The events that happen on the game events, right? We looked at the events and signals we can get from events the other day. The input signals, input events, the collision event, the area or region events, things that can happen. So that's what I put in my notes, but like that I use the word cause. So cause and effect. It's a standard principle in the universe. But when the same cause has different effects, the actual definition of random. Unpredictability to a substantial degree.
Be able to come up with a mathematical formula for detecting the lottery.
Not detecting it, but the probability of it, stuff that it's unpredictable to a substantial degree. That's that particular one. If you're thinking about like the bingo, the balls bouncing around, being blown around by air inside of a chamber. So a fan, it's like if you haven't ever seen the inside of those lottery machines, it's kind of like a miniature leaf blower or hair dryer. without the heating elements that spins. It's mounted but off balance. So as it blows air, it bounces around without really moving, and that moves all those little ping pong balls and then those cubes that pop out. So that is getting into nonlinear dynamics. So chaos. So predictable.
Yeah.
But predictable like the weather. Only maybe the even a more extreme example. It's getting into chaos, but yes, it is. It is predictable, but it would fall this degree from stochastics, substantial degree that we're not going to sit there and calculate it. Kind of like random numbers in computers. It's not random. We could definitely predict what that is, and we do that when debugging a lot, right? You all ever set the seed on your random number? When debugging, we need things to happen consistently so we can repeat bugs. So the random number starts with a particular value. Usually it finds something off the clock or the date or the temperature. It just grabs some number from the universe. And then it uses that to feeds it through a complicated formula to come up with uh, some highly unpredictable number. But that makes debugging hard. So we can also just hard code the seed in there. We can say start with 3 every time. So that way we get the same random number every time we're debugging our assignment. It's highly predictable. I just wanted to throw up the actual definition of random if you haven't encountered it in math class before, because that's going to be important in game development, right? Similar causes lead to dissimilar effects. So a good place that would show up in games might be your NPCs wandering around town. Just because the NPC walking east on the street through the village doesn't mean the NPC is going to turn around and walk west while they're waiting for you to come up and interact with them. The next time they walk east, they might decide to go north, or they might wander into one of the village huts or something. Different things happen from the same events, but the same code is the same. There's probably more concise code controlling the NPC. And if you're getting into game development and start digging into making things, getting better control over that, you're going to encounter the math notation. So part of it is just to see the notation. Has everybody encountered functional notation somewhere along the way? Probability of some event. So A is an event. The thing we want to happen. The probability that this event happens. It's same function notation we use in program, right? The name of the function followed by the parameters inside of parentheses. Just usually in math class, we use a single letter instead of actually writing a word because we're writing it on paper or boards. So this is the probability of event A. And A is going to be whatever event we're worried about. Flipping a coin, we probably use an H in that case. And that would be the probability we get a heads. We'd use an H for there, or for rolling a traditional 6-sided die, might put in probability of 5. That'd be the probability that we get a 5. So, which the simple formula for that, I'll write out in words, is the number of times A occurs divided by the total number of possibilities. So hopefully everybody's seen that before, right? Maybe not the notation. And I wanted to include the notation because if you start, as you progress further and further down game development pathway beyond this class, hopefully you're enjoying it and gonna keep doing it. And you go to look things up, you're gonna encounter the formal math notation along the way, so make sure we can read that. There are restrictions on this. So I'll put the word if there. Programmers know what that word means. So if the probability of event A is equal to 0, that means absolutely no chance. It's something that will not happen, right? In our universe, finding things that 0 is very, very unlikely, but something, yeah, the absolutely no chance. There's no way it could happen. Earth isn't going to suddenly collide with Jupiter. If Earth and Jupiter ended up on a collision path, we would know about it millions of years in advance. Because Jupiter was a long way away. So it wouldn't, but from the current paths of both planets, there is no chance of that happening. Like this afternoon. Well, that might be a better way to say it. There's no chance of it happening this afternoon because if Jupiter and Earth were going to collide, we would know about it millions of years in advance. There's absolutely no chance the moon's going to go in front of the sun today, right? We've already passed the new moon. The moon will not go in front of the sun again until the next new moon. And odds are of the total number of places that could happen versus the total number of places on Earth, most of them are in the vast expanse of the Pacific Ocean. So it happens every month over the Pacific Ocean, but or almost every month. There's some ups and downs and wiggle room there, but it happens all the time over the Pacific Ocean. But when it happens over, like, say, a huge strip in America, that becomes a big deal that we know about years in advance. Usually the eclipse is 0% chance. And the other end, probability of 1 is absolute certainty it will happen. That's things that we know for certain. This one's not true, but when I drop this marker, we know with absolute certainty it's going to fall down, right? 100% chance it's going downward. That's technically not true in our universe because, but for the sake of example, let's pretend like we do have absolute certainties in our universe. Jupiter's really, really big. The gravity from Jupiter could lift things back up. The moon could lift it up, but we know it's probably not going to happen. And by 1 here, that's 100%. So usually we say those percent. Y'all hopefully encountered that before. So this is a very important one to keep track of in game development. So this thing that you hopefully heard before, the probability of an event occurring is somewhere between 0 and 1. And if you get out of that range, if you pass that range, your game's going to seem a little off. And by past that range is really the next thing that shows up on the board, because obviously we can't pass absolute certainty that something's going to happen. But again, this is the boring section of probability. Okay, if I erase this side over here and start to get into the more interesting parts, when there's more than one thing happening at once. So those are the ones we got to worry about. Because if we have several things happening at once, we still have that last restriction. Flipping a coin is a good example. It's either, I'm going to skip the side. Sides are more interesting. Spinning a coin is more interesting than flipping it, if you've ever encountered that. Because in order to come out of a mold, coins are beveled. So we don't have exactly perfect odds of which way it's going to fall if we spin a coin. Like if you stand it on its side, they're beveled to come out of a mold, so they come out of the press easy at the end. But when we spin it, that's going to very drastically change which way it falls. It's going to try to fall this way, but it might have momentum that'll pull it the other way. End up with way more interesting things spinning a coin, but flipping a coin where it's going to land on one of the flat sides is it could land on the side and stand upright, but that's really that's done in this range. Everybody would be amazed. Everybody would grab their cameras and share it with everybody they know. Just having seen that happen once, like, yeah, I knew it was possible, but didn't actually believe it ever would. Flipping it, it's either going to be heads or tails. So 50-50. But everything that could happen is an event. Probability of every event that could happen has that same restriction between 0 and 1. And that's the one when we start writing our code, we can actually accidentally violate. And we can make some events that should contradict each other not contradict each other, and then we end up with more than 100%. And more than 100% chance on all the stuff that could happen. Probability is not a statement about reality. That example I used, dropping the marker, said there's a zero. If I let go of this, there's a 0% chance it's going to hit the ceiling, which isn't important. Several people missed this on the quiz. What's the velocity of this marker right now? 0. So a velocity of 0 by Newton's law is going to stay at 0 unless something acts on it.
Releasing it at that.
I release it, then gravity can act on it. And it goes from a velocity of 0 to some non-zero velocity, which means gravity is an acceleration. I think part of it is you've heard in America, it's common to say force of gravity, but that of makes a difference. Gravity is not a force. Gravity is an acceleration that creates a force. The force is weight. It got a bunch of people. But yeah, if you think it through, it gets everybody in physics 1. That's the question that is like you count on almost everybody's going to miss when they take their physics 1 class. Is we think about, well, in America, we hear that phrase, force of gravity, but the of makes a difference. Force of, the force created by gravity. But has a velocity of 0, and when gravity acts on it, the velocity changes. So gravity itself is an acceleration. But we know for certain it's not going to hit the ceiling, right? That's an important thing with probability, because not by the laws of physics. By the laws of physics, it's very unlikely it's going to hit the ceiling. Even less likely that it will move through the ceiling on its own, but not impossible. It's not a 0 or a 1, either one, by the laws of physics. Especially if we get into quantum mechanics. So, an important note is probability is not a statement about reality. It's a statement about your belief in reality. What do you think is going to happen when this falls? When I let go of the pin? Odds are it's going to fall down. very, very drastically, odds are it's not 100% absolute certain. But if we wrote it out, it'd be like 0.998, a whole bunch of nines in that certainty. And there's the very, very, very small ones that is going to go the other way. Paper's more likely to go the other way. The air conditioner's on. I was listening to see if the air conditioner's on or not. If that vent right above me was on, it would be more likely to go up briefly before it comes down. Right now, it's probably 50-50 on whether the paper goes straight down or up. And what's going to make a difference, if it shows on the camera, is how quickly I pull my hand away. If I just let go gently, it starts going down. But if I let go vigorously and create a little vortex, I don't know if I'll make it work there. If I let go vigorously enough, the air pressure off my hand is going to blow it back up briefly. I don't think we're going to see it, but hopefully that makes sense, right? My hand moving is going to create a little bit of wind and it'll very briefly lift it back up. It works way better when air conditioning units are blowing because then there's already moving air, so it doesn't move much more. But not going that much. So, not a statement about reality, it's a statement about your belief in reality. And here's the two important ones. The probability of all possible events. Add 2, 1, or 100%. Or is the keyword means divide and cent, like century, penny. So divide by 100, and we just add a couple more places over there. This end, which is just a way to make floating point numbers easier to say. Mathematically, that's going to look like this. Erasing the Greek letter sigma is usually used for some. So when you go looking things up, you'll see this one a lot. Some little index, I'll start it at 1. We add up all of them, starting with our first one, going off to infinity. On every single event that could happen, little subscripts like that, all adds up to 1. Again, a lot of this is going to be notational because when you go to look stuff up, trying to figure out what you need to do to make your game behave the way you want it to, you're going to come across the formal notation. So we'll make sure we can read that. We can turn this around. We take this, so 100% minus the probability of A will give us the probability of the complement of A. So the rest of them, complement means the rest, the others. I'm pretty sure by this point everybody's heard complement and binary. A 0 or 1, 1 or a 0. If we're flipping a coin, heads or tails. If we're rolling a 6-sided die, any number, right? The probability of 3 is 1 out of 6. Because each number is going to be on one side, and six total sides. There's 1 3 on it, so 1 out of 6. So then 1 minus 1 6, so there's a 5/6 chance that we get a number other than 1 2 4 5 6. That's an important thing, and that shows up in coding quite often because sometimes this is an easier number. This number is an easy one to find, but this is the one we actually want. So we can build up to the probability of the event that's easier to think about, easier to pull the values from or determine what they are But it's actually the rest, it's actually, we want not that. You can think of it that way. When we're worried about about something not happening. That's the formula that. Really easy thing to code. Like to code it, we just move the equal sign. Y'all know how to write code. I put a little C here. If you can't see that, that's a compliment. The second most common notation for that might be a bar over it. We actually read that a bar, probably an a bar, but it's a lot easier to see than just a little C up in the corner. Okay, if I erase this side. All right. So, yeah, the basics of probability. Hopefully, you saw this part before. Oh yeah, 40 minutes. Okay. Yeah, this is like the physics. I don't want to do this lecture without the notes in my hand because I 600 level probability classes. I definitely don't want to leave you all confused. We just need sort of like the physics. We just need some basic intuition on them. Sometimes we have to look it up. Some of the notational stuff. This next one we will probably use at times. So when two events are mutually exclusive, that means they do not affect each other. They're exclusive. So a traditional example for mutual exclusivity is you flip a coin and roll a die. Six-sided die, flipping a coin, those are standard examples. So if you do both of them at the same time, right, roll a die with your left hand and flip a coin with your right hand, they have no impact on each other. Getting a heads doesn't tell you anything on the coin, doesn't tell you anything about what's on that die. Or getting a 4 on the die doesn't tell you anything about what the coin flip land is. They're have nothing to do with each other other than a Venn diagram. When the Venn diagram looks like that, nothing about event A is going to affect event B. Just kind of like saying the chance of one or the other is their sum. I'll write it that way. Chance of one, spell it out. One or the other is their sum. Word or there is very important. Something that I learned actually right before I got my bachelor's in math. Some people apparently don't hear it until they're like nearing the end of a bachelor's in math. I heard it in 4th grade. I heard other people say they learned it even earlier than the years I point back to. Add the ors and multiply the ands. We all heard that before? Okay, so of the two in the room, I got one head shake no and one head shake yes. It is across the board in mathematics. Last time I taught this class, I pulled out a trick question where we said used as and in a situation in the English sentence that actually before to make it a little tricky, but I don't want to trick y'all. So I'm not gonna do that example this time. But when it's actually proper use of or and and, that's across the board in mathematics. Add the ors and multiply the ands. It's keywords to look for in word problems, things like that. So mathematically, that's gonna be a union. I'll do A's and B's because that's what I wrote in there. The probability of A minus the probability of B. If they're not mutually exclusive, this formula extends. But instead of adding more notes and doing a second version of this formula, I'm gonna add it on here because it'll cover both of them. Let's go on the board over here. So a side note, another Venn diagram. This is not mutually exclusive. I use it with the picture. So if they're not mutually exclusive, and we started doing the odds, we'd count everything in that first circle, right? Over in circle A. Then we count everything over in circle B, but if we do that, we counted everything in that overlap twice. So this formula can extend just, whoops, sorry. Yeah, right, like the words above it say, add, which is that symbol, not the minus sign. Yeah, so add the chances of each one. But then if they're not mutually exclusive, that means there's an and situation in there as well. There's some overlap. And if we start counting all the possibilities, back to the basic formula of probability, that overlap's going to get counted twice. On a deck of cards, if we draw a random card, what are the odds that it's a spade or a face card? Like we have 13 spades out of 52 cards, but or a face card, then there's 4 in each suit, or 3 in each suit. So 3 times 4, there's 12 face cards, but we counted the face cards from the spades twice. They counted as spades and as face cards, so we need to subtract one of them off. So minus the overlap. Probability of event A intersecting event B. Which is typically given as 2 separate formulas. But if the things are mutually exclusive, the overlap is 0. So then we're subtracting 0. So I think it's a lot easier just to remember one formula instead of overcomplicating it. But add the ors. And we're going to skip not mutually exclusive intersection because that gets really, really complicated. In game development, you're going to have one of these situations. The things that are related to each other. So rolling 2 die from the same hand, they bounce against each other. That's going to make a difference. Yeah, dealing cards. Card games are going to be like this because our odds change once some of the cards are out of the deck. At the first card, we have some chance out of 52, but then the next card is just some chance out of 51 of getting that card. So they're related. They depend on each other a little bit. That's the only ones we'll see in game development. This is an important formula though, and I'm going to give you a formula that'll work for that. Okay, if I erase this side. But remember this, sometimes you want the complement, but it's easier to find the actual, which our words would change. If that's what we're looking for, we'd call that the actual, but it's easier to find the complement of it. And then we can just subtract that from 100% to get the one we actually want. And in game development, that happens a lot. So like situationally, your NPCs are wandering around a village and the odds they turn a certain direction or another might be somewhat dependent on what the other NPCs are doing. So figuring out that what the other NPCs are doing or where your character is standing might change the odds. And it's really, really easy to figure out where your character is standing. That's a good example. You're gonna have to start. They're gonna go some direction, different direction every so often. Unless your character's standing there, but it's a lot easier to find your character's location. Which would be the complement of the thing you actually want, which would be. So it's easier to find that, figure out what the NPC is gonna do based off the complement that way. For intersections, I already used it up there. Probability of A intersects B. Multiply the ands, add the ors, multiply ands. I'll do a traditional example. These are best done with a chart. So certain things can happen. Let's think about people. We have men and women. And let's just assume brown eyes and blue eyes. Brown eyes, blue eyes. Let's cut off the other colors. There's a lot more colors to humanize than that. It gets very, could get very detailed, but let's go with a simple one today. Everybody has either brown or blue eyes. So to find odds, we would start calculating. And these things they're not mutually exclusive, right? Let's also disregard the people that would have different colored eyes. So everybody either has brown eyes or they have blue eyes, but nobody has both. In real life, some people have both, but for our simplified example, let's go with it this way. And then we can make a total row in our chart. So let's just count some people. What I put in my notes is maybe we have 3 guys with brown eyes and 2 women with brown eyes. And blue eyes, there's 1 man and 4 women. So 5, 10. So out of 10 people, and we can just fill out our chart. Total rows are easy, right? 3 plus 2, 5. 1 plus 4 is 5. Gives us 10. Then we can come down this way. 3 and 1. 4 is 6. So if we choose a random person, what are the odds that the random person from this group is a brown-eyed man? Everybody see how you got that? There's 3, it happens 3 times out of these 10 total people. So brown-eyed male is that simple probability 3 out of 10. But we get into more interesting things, and this is where it starts showing up in our games. I put on the notes, use a role-playing RPG table. So this sort of table could extend out to like armor types. The type of helmet you have is going to affect. We have a column for helmets, and one of them blocks 80% of damage, another one blocks 50% of damage, another one blocks 10% of damage, and we build this sort of table to figure out the probabilities of what happens in in combat with that character. So this one shows up a lot more where we can start doing more interesting things. So let's say brown-eyed male or brown-eyed female, based off the label I put there. So what are the odds on this one? This one you can probably guess, because the table is split up kind of nicely, but
It'd be 5 out of 10.
yes, but to get there, we'd use this. It's or, right? Can't be both. Right, we wouldn't pick a label. So that's a big deal in our society these days, right? Those labels can change, but we still pick one label. So it's an or situation. It doesn't happen both ways. So the probability of brown-eyed males, 3 out of 10. Or, so we'll add it, and 2 out of 10. This is 5 out of 10 or 1/2, 50%. Probably the easiest way to say it. One more of the simple ones, not a blue-eyed woman. For some reason, I use female on the label. Seems odd to say that now, but not a blue-eyed female. What are odds of that?
Six out of 10.
Yes. And that's that. For that, we can use the other formula, right? So it's really easy to find which ones are blue-eyed women. Go back to just normal English when talking about that. We know that 4 out of 10 are blue-eyed women, and we know that everything should add up to 100%. So that's where that 1 minus formula would come up. 1 minus 4 out of 10. And we're left with a 6 out of 10 chance. In games especially, the examples get more detailed, more complicated, or get a little complicated at times, because really digging into that happens in much games than we'll think in classrooms. It's sort of games that we would have to spend every moment of our class time working on the same game the whole semester to get to. But the big interesting ones, this is often easier to find. What's not the thing we want. So sort of negation. By this point in programming, everybody's encountered the logical operators. And a lot of times the not is easier. So when our events are mutually exclusive, or just independent of each other, we can just multiply it. These are kind of independent, right? There's no crossover, right? We simplified the situation, so disregarding the people that have the different colored eyes, saying everybody has the same colored eyes. So they're either in this group or this group. Going this way in our table. We go this way in the group, our table, they're either in this column or this column, but not in both columns. So they're mutually exclusive. Being in one cell of this table is not impacted or does not have any impact on another cell of the table. If somebody else joined our group, we could just add them to the table, and it's only going to affect that one cell and then the total. But every other cell that they don't block they don't fall into stays like it was. For that, we just multiply them. So notationally, because when you get up to the interesting stuff and start doing it, and you look things up, you're gonna see the messy notation. The functional notation from math and just the probability of each one, but in this case, maybe a question like odds of a brown man, I better use the same labels. A brown-eyed male or blue-eyed female, and a blue-eyed female. All of those things are independent of each other, right? Or just the and here, right? Just to get to the brown-eyed male. Chances of being a male are 4 out of 10. And chances of having brown eyes are 5 out of 10. So if we multiply those, we get 20 out of 100. Wait, that didn't come out right.
Did you mean to multiply the 10 times 10?
Yeah, I said something wrong there. This is an and situation. So a lot of times when we have the tables, we can read the ands from it. So brown eyes, brown eyes is 3 out of 5 and 3 out of 4. So it should be multiplying 3/5 times 3/4 gives us 9/16, which is still different than 3 out of 10, but it's pretty close. Sort of, there's some randomness worked in there, but this is the actual count one. No, not 9/16, 9/20 would be the correct value there. Sorry, I should have wrote that down. So our ands correspond there, but whenever it gets more complicated, so brown-eyed male is, the chance of that is 3 out of 10. And the chance of a blue-eyed female would be 4 out of 10. Or 12/100ths, which is 12%. That's the one that you'll end up doing a lot with. I will try to work in an example to a game, a small one next week. We're restricted on time today. Actually, I need to go grab my suitcase, start grabbing my suitcase and stuff here in a few minutes, but you can put things out in a table. So like in an RPG game, instead of this traditional example of men and women, you have the helmet that the character is using. And then we have a bunch of different hit levels that we get from that. And some probabilities of how much it's going to decrease the damage. The same thing with the armor the character is wearing. They have heavy steel plate armor, or just wearing fabric. And we end up with tables like this and get down to probabilities. And then those probabilities are what we mess around with those probabilities to get more realistic damage taking in a role-playing game. Right? If something came down to 12%, we'd want to then use that 12% on whether or not they take damage. It's not that their damage is going to decrease by 12%. There's a 12% chance they take damage, which leaves a 88% chance that they don't take damage, that the armor is effective, and that gives it a much greater sense of realism. And we can just kind of fill out a table from that, and then do the simple calculations like that. But that it happens in a lot of places. that's the one that's most likely, that you'll most likely have to do calculations. You come up with a table, which you can just print the table out for the game. Right? While you're debugging it or putting it together, just hit print at a certain point and see what numbers you have to work with. But service tables, right? So these are a two-dimensional array. So you can start multiplying things out to find the odds. That one does show up quite a bit in game development. Is it okay if I erase this side? One more formula to put up here. What were you asking?
I forgot.
Okay. Yeah, one of the biggest things, we're under tight time constraints, so we're not going to be working a lot of fancy probabilities into our games. This one is what shows up most often in game development. You put that table together, your things are somewhat mutually exclusive. And you can do that. There is another thing that could happen. Sometimes things happen sequentially, especially in a game. I'm just going to put that word. Sometimes things are sequential. Keyword for math would be given, or I guess you could say given that. Let's use the eclipse from the other day for an example. What are the odds of an eclipse given that it's nighttime? Right, nighttime, so 1 o'clock in the morning, 1 a.m. What are the odds of seeing a solar eclipse? 0, right?
I mean, it would still happen, just not for your visible.
Yeah, I mean, actually seeing it. Yeah, they happen all the time, but yeah, most eclipses happen over the vast expanse of the Pacific Ocean. So you have to be really good with the boat to get to the right spot to see them anyway. There's a 20-mile stretch on land, like what we had in Indiana the other day, is easy to get to in a car. But if you need to narrow your position down to 20 miles somewhere in the middle of the Pacific Ocean, that can be a bit difficult.
Waves.
Yeah, everything's going to push you out of that 20 miles pretty quickly. But it depends on it, right? Seeing the solar eclipse depends on whether it's nighttime or daytime. Notationally, and this one's going to show up a lot when you're researching things for a game, trying to get some interesting probabilities in there. It uses the vertical bar. The probability of event A given that B has already happened. Probability of event A given that B already happened.
Popping an event from a list, and you just pop it again, and that way you can't like do A again.
Yeah, things like that. It's hard to come up with examples of exactly where this is going to show up. But this one will make your game seem a lot more realistic. So this is a notation you will encounter a lot when you start trying to do research into probability to make your game more interesting. Yes. So it's the probability of, the formula for it is the probability of A intersecting B. So that and, again, divided by the probability of B. Logically, like B already happened. It's in the past, so it's certainty. We already know that happened. Right? For example, if I throw that to the side now, what's the probability I'm going to pick up that paper before the end of class?
Pretty high, hopefully.
pretty high, but we don't need the probability of the paper being on the floor. Right? Because the paper's either in my hand or on the floor. Let's simplify it there, so that 50%, we don't need the 50% chance that that paper is going to be, could be on the floor versus in my hand, leading to picking that paper back up. Hopefully that example helps with how you might need to use that in order to apply realist in the game. But when things happen, we need to look at what's already happened.
You don't know what's happened until you look into the box.
Yeah.
I think it's about probability. Right?
Yeah, that was the last thing in the notes, so yeah. I don't need the notes again, so that makes it even more difficult to calculate the odds whether I'm gonna pick them up or not. Just the being bothered by paper on the floor. Will it bother me that much before we wrap up here in just a few minutes? Generally, when coding probabilities, which we're running short on time, so I'm just gonna do this in a text editor instead of even opening the browser and stuff. Generally, what we're going to do, and the best way to think about it, best way to think about probabilities is think about rolling dice, and think about rolling dice and D&D. Everybody has at least a basic idea of that, right? Yeah. So break your probability down to a 20-sided die. So let's say NPC turns while pacing. So the NPC is pacing around the village, and they're going to turn. Which way are they going to turn? So we would probably pick a random number. So turning is some random number. I'll do random int. This isn't it. This is notes, just because we're very quickly running out of time. I need to wrap up in like 2 or 3 minutes.
You can do
And
it
get going.
random, right?
Yeah, it's for Godot it's randi, but you can easily Google that. Again, an important thing is we do not have time to see all of Godot, so we need to see part of this class is going to be finding. Oh, I was jumping off what you just said. Part of this class is going to be finding good reference material. So look up random and random integer in Godot and see which reference site you like best. Which YouTube tutorial you think, which person's YouTube tutorials you think you like listening to that person, or go straight to the documentation, right? Look for those good resources that you get the most out of. So random int, somewhere between 0 and 20 in the actual syntax, and then we can just kind of break it down, right? The NPC can either turn several different directions, turns while pacing. I think there might be time for a couple of versions. Then we can just do an if else. So if turning is a less than 10, new direction equals north. We probably do all that with vectors and stuff. There's just some pseudocode, so I'll spell this out. Otherwise, turning could be less than, say, 14. Direction equals south. Else if turning is less than 19, so do a 180 and go west. And then there's only one left, but I'll go ahead and write it out. Oh, I guess I'll just do the else. There's only one left, right? Whoops. So 1 and 20. We're not actually writing the code here, just pseudocode. should have done 1 and 19 and 20 values inclusive. Otherwise, on that last one, direction equals east. So the NPC is most likely going to walk north, but there's no guarantee on that. And it can make the game a little bit more interesting. I almost clicked on it, so I didn't. I forgot that in the probabilities. Paper is slippery. Paper on floor is dangerous. Gonna make it a little more interesting because every time we come to that village, it might be harder to find where that NPC wandered off to. Because at any given, right, every so often the timer goes off and they turn a different direction, and it's most likely going to be north. That gives us an idea, but there's no guarantee. They could just randomly get that east every time, and then the player goes straight east, or they could get a bunch of south. I could extend the south. Like, so only a small chance they go south, but it could keep happening. And it makes it harder to find that NPC every time we come back to that village or whatever. That's how this stuff generally applies. The givens would be this formula, right? The intersection is we multiply the odds. So in this case, the odds of going north would be 1/2, 10 out of 20. Given that it was previously moving west or something. That's a bad example. This formula gets it. This shows up later. That's why I was focusing more on notation. So that when you're getting to those complicated games, it's really hard to come up with examples that are quick to visualize. But when your games get more interesting, formulas like this become more and more important. Like, given that it's daytime, this might change. So like we do this at day, but at nighttime, it'd be an even more of an even split. If turning is less than 5, direction equals north. Else if turning is less than 10, direction equals south. And I can just copy those other two. And does that kind of make sense? Because in the day, it's a lot easier to tell which direction north is. So if that NPC wants to go northward, during the daytime, it's a lot easier to tell which direction north is. But at night, especially if we've got fog and clouds and stuff in our game to make it look a little bit spooky, it's a lot harder to tell which direction north is. So there's an even chance that at any interval, the player is going to turn a different way. So that's where we would look for the realism. If we go start researching things to make it real, we're going to see these form this notation, which looks like a mess. But it's the opposite of physics. Physics look nice on the board and then mess in code. Probability looks like a mess on the board, but it just, think about rolling a die in D&D. Choose the number of sides and then just an if else for that number. It's kind of how it goes into code. So that part's fairly straightforward. I guess I'll push the physics material back to Monday because I gotta do that. I can give you this link though. I'm gonna share a link in the chat before we wrap up. Does anybody have any questions about probabilities? Probably, right? That's very quick coverage.
Well, I'm trying to think of something. But now all I want to do is make a tool to create weighted probabilities. Like have an item and then just like some random number and collect all the numbers, crunch them up to like, you know. So the weights divided by total amount of weights for all items, and then actually put a float or integer between 0 and 100.
That makes sense. Yeah, weighted averaging on things that can happen, and then you just have a like little interface to plug in. But there's some sort of probability, and really when it comes to coding it, right, really when it comes to coding it, you're coming back to if else statements. This is gonna happen or that's gonna happen. And over the years, I found it's easiest just think about that in D&D because we have all those different die.
Yeah.
Are you rolling a 4-sided die, a 20-sided die, a 100-sided die? Are you just scrolling the sphere and seeing what number is upward? Does it have so many sides? It might as well be a ping pong ball and roll smoothly. But try to think about it that way, and it helps to put that into the code. So coding, it's easier than this. But when you go research stuff, you're going to see the actual mathematical notation. So hopefully that notation stuff made enough sense. You can turn that back into a formula and break it down.
I only did to not mutually exclusive.
It could be a little, yeah, that one gets problematic. Independent would be a regular English way to say it. Those things are completely independent of each other. Or mutually exclusive is not.
Like dependent.
Mutually exclusive, they do not affect each other, so they are independent. Not mutually exclusive would be dependent.
Yeah, so that would probably be. I think keep going back to RPG terminology. That would be like random enchantments to a certain piece of gear.
Yeah,
Okay.
yeah, the gear, there's helmet, like so many points on its own, and you guys.
I will say checking your probabilities is pretty important in some games because I always keep coming back to it. Destiny 2. We had a little while ago. There was well, not a little while ago, a couple of years ago. They introduced a bunch of new weapons into the game, and for some reason, some coding mistake, Edge Transit was like a 1 in like out of all the basically there's world drops where it's like a huge loot pool of just anything and everything they just toss in there that can just pop out of it. And for some reason, you could count on like 1 out of 3 or 4 being Edge Transit. Like it was the single most dropped item in the game's entire 10-year history at this point. So much so that now that they're doing a event where they're bringing back they're reprising some of the greatest weapons that from the game's history. They put it in that list because it was so well known to the community as just a nod slash ha ha at their own screw up of making that thing basically the only weapon you could find.
Yeah, it definitely ties back to that, like you were saying. So he does show up. It's just hard to come up with the examples. But y'all have probably seen other examples, not necessarily none of these point out the most famous one. Probably thinking of someone. You just look for the day because we'll buy a whole new box of snacks to the next event. So that's what they're here for. So here's a little thing to use for lab. This covers some physics in the full game. It can hopefully get started. I was wanting to talk about the physics materials. I'll talk about physics materials Monday, but that took a little bit longer than I was thinking, and I need to grab my suitcase and get going. But basically, this video is an hour long. You make a bunch of pool balls, apply all the physics, and the pool game is based off the laws of physics, not all, not all hard-coded movement. So the way this circle hits this circle, the laws of physics pass through. So that is a good one to work through. I didn't have any trouble watching it at double speed and using the pause button, but it's only an hour at normal speed, which is still less than the amount of class time we're having to cut today because I have to leave early. Does anybody have any questions about stuff from today? If you can give it 3 seconds, I need the carpool is about to be waiting on me out front. And my car is way in the back, so I have to go in case I'm gonna be late. Okay, I assume that signs me no questions. I don't know what my internet access is gonna be over the next couple days or time to check emails. I will get back to you as soon as I check the email, as soon as I get it out. I'll still be checking email several times a day, but I'll be back to normal routine on Friday. Y'all have a great day. I'll see you next week and we'll pick up with physics materials and Godot. See ya.
Schedule.
Bye. Have fun at your event.